Thank you. Important example number 18. Apparently example 18 is kind of important. And Garrett was in this morning asking about an example on the worksheet or problem on the worksheet that related to this. What? Okay, so here we go. It says if f prime is equal to 2x squared and f of 0 equals find f of 2 by finding the particular solution to the differential equation. All right, and then evaluate the solution at 2. Okay, so we're after f of 2. That's our ultimate goal. That's the function value at 2. We don't have the function f. We have its derivative f prime. So if I need to get to f, I need to find the antiderivative of that, right? But when I do that, I'm going to generate an unknown value plus c. So here's your initial condition that allows you to find the particular solution to that differential equation. And of course, once you have the particular solution, you can then evaluate it at any value you'd like. We're going to evaluate it at 2. So that's kind of how we're going to do that. So here we go. I'm going to integrate f prime of x. And you don't have to show that step. You can go straight to this step here. And here we go. We get 2/3 x to the third minus 2x, and then, of course, plus c. And we're going to call that f of x. So if you want to kind of throw that on the left side here the whole time, you could do that. So anyway, we have what's called a general solution, if you recall that, to the differential equation because it has plus c. The plus c is going to affect the graph how, ultimately? Shift it, right? Vertical shift. And we want to find the exact value of c so that it's passing through the y-intercept of 5. So some kind of pre-response question explanation about what you're doing from here to the next line. So how about at the point 0, 5? Was it 0, 5? Yeah. Or you could say for f of 0 equals 5. Something like that. It just says, hey, I'm about to plug in this ordered pair. You get 5 then equals, when I plug in a 0 for x, I get 0 plus 0 minus 0, sorry, plus c, which is c. So c equals 5. Box it up. No, you don't need to box it up. You can. So, comma, f of x equals 2/3 x cubed minus 2x plus 5. There is your particular solution. And now that I have the particular solution, I can evaluate that cubic polynomial at any value you want me to. Well, I got to do what this one wants me to do first. So you're second in line. F of 2, no problem. I'll just communicate that by writing f of 2 on the left because I know that's important. And here we go. We plug it in at 2, and we get 2/3 times 2 cubed, which is 8. Minus 2 times 2 is 4 plus 5. And free response, we're walking away. In fact, I probably wouldn't even have cubed the 8 and expended that mental energy. But here we're going to keep going. 6/3, that's going to be plus 1. And 1 is how many thirds? 3. So we get 19/3. So there's f of 2, 19/3. Sweet. 6.33333333. That wasn't too bad, was it? That was kind of a review. We've already done that. We did that in 4.1, I think. 4.1. Is there another way to do it? Apparently, I think there is. Okay. Can your TI calculators give you that answer? Would your calculator help you to do this problem this way? No, unless you have like an 89 or an old-fashioned 92, your calculator cannot find equations of antiderivatives for you. Okay, and remember, that's what this method depends upon. It depends upon you finding the antiderivative. Your calculator 84 family are number crunching machines. So we know that it can't handle indefinite integrals, but it could handle definite integrals, right? We've seen that. So my question is, can we write this problem and get the same answer using a definite integral? And the answer is, I hope so. Yeah. Okay, so, hey, it says to try it, so let's give it a try. Here's what we're after. We're after f of 2. That means we want to find the y value at x equals 2, right? Nothing fancy about that. So here's an important idea, and see if you disagree with it. What you or I or anyone, what one has at any moment, and you can decide what it is you have. Okay, but what you have at any given moment is right now a function of two things. Number one, what you started with. What you have right now. And you could, again, depend upon the starting time, it varies. Plus, number two, what you've accumulated, net accumulated, since that time. It doesn't matter what you're accumulating, okay? Like you're talking about money. Like yesterday, I started with $5. And since then, I have accumulated negative $3. Right now, I have 5 plus negative 3, $2. Or you can say last week, I had $40. And since that last week time, I have accumulated negative $40. But I am soon to procure two boxes of cookie dough. One from the band and one from the track team. So, yeah. Last week, I had 52,000 confidence units. And since that time, I have accumulated one more confident unit. So now I have 52,001 confident units, right? Doesn't really matter. What you have at any given time is a function of what you started with, plus your net accumulation since then, right? Make sense? Anyone disagree with that? Good. That's convenient. So here we go. We're trying to figure out what we have at x equals 2. And by what we have, we mean y values. We want to know what is the y value at x equals 2. So it's a function of the y value we started with. Well, what y value did we start with? The initial condition. We started with a y value of f of 0. I'm just going to go ahead and write it as f of 0. That's what we started with. Plus the accumulation from the time we had f of 0, which is at 0, to the time we're getting to now, which is 2. So how do we show net accumulation in calculus? The integral from when we had f of 0, which is at 0, to where we're trying to get to, of the rate equation that tells us how fast we're accumulating things. What's the rate equation of f? F prime, right? Dx. There you go. Hugely important idea. So here's how you would read this mathematical sentence. The y value you have at 2 is a function of the y value you started with at 0 plus the accumulation of your y values from 0 to 2, where you started to where you're trying to get, of the rate equation that tells you how fast you accumulate y values, which is its derivative, y prime, or in this case, f prime. Okay? Super important idea. This one expresses f of 2 directly, succinctly. We don't have to do it as like a multi-step process like we did down here. We could do it directly. And we can also do it on the calculator, because your calculator can handle numeric integrals. Well, we're going to save the calculator to the end. We're going to do this one by hand. Here we go. So apparently f of 2 is equal to f of 0. What is f of 0? 5. Plus the net accumulation from 0 to 2 of f prime, which of course is 2x squared minus 2. And if we evaluate that, we should end up with what? 19/3. Let's see if we get it. I'm going to work down at the angle here. So f of 2, 5 goes along for the ride, plus the antiderivative, 2/3 x cubed minus 2x. Do we need plus c here? Nope, it's a definite integral, so from 0 to 2. And so we get f of 2, I'll keep writing it, equals, 5 is still just standing out there waiting for his turn to combine with somebody. Plug in the top and you get 8 times 2 is 16/3 minus 4. Minus plug in the bottom and you get 0. And so now you can drop the parentheses and the brackets and you can tear down the walls and unite people. The 5 and the 4 can get together and call themselves 1. Oh, that's romantic. Plus 16/3. And then you get 19/3. Which, of course, I think is, as I already said, right, 6.33333 all of them repeat in chunks. Pretty cool, huh? Pretty darn cool. I think so. Let's see if the calculator knows how to do that. So here's again the advantage of being able to express it as a definite integral. You don't need to be able to find the antiderivative if it's a calculator question. How am I supposed to stretch it? There we go. Come on. Nope. There we go. There we go. Okay, so what we just did by hand, of course, as you recall, does still require us to find the antiderivative. But if you can't find the antiderivative, because it's not always possible, or the antiderivative is not really in existence, numeric methods still are viable, and your calculator, remember, does things numerically. So if you can express that as a definite integral, you can compute it without having to know the antiderivative. So here's what we would do. Once we write it down on our paper/iPad, right, this right here, this is called your integral setup. And that's probably going to get you 2 points, believe it or not. One for the integral setup and one for adding the initial condition 5. The final answer then is only worth 1. So again, once you demonstrate that you know what you're doing, the final answer is almost trivial, okay? It's just a matter of can you get it into your calculator correctly, if this were a calculator question. All right, so here we go. We'll just type it in, 5 plus, and then math 9. This is, again, another reason we do it from the home screen, not the graphing screen. We can add 5 directly to it. 0 to 2 of 2x squared minus 2 with respect to x. Is this the FTOC part 1 with the starting point added? Yes, essentially, yeah. Because the FTOC part 1 just gives you your net accumulation. And if you add to your net accumulation what you started with, you get your current amount. So it's kind of the difference between displacement and current position. You see the connection there? The definite integral gives you your net change, which would be your displacement. So if you're talking about motion, what is the net change in position? What's the displacement? But if you want to know the current position, you would need to add it to the initial position. So if I was on I-35 somewhere between here and Minneapolis, and I just called you and said, hey, I'm 20 miles north of where I was 10 minutes ago, you'd be like, ooh, don't let the calculus cops catch you, right? You wouldn't know where I was, right? You wouldn't know if I was in Waco or if I was in, Rochester, New York or something, or I guess not New York, but Rochester, the one on I-35, Minnesota. Similarly, if I just told you, hey, 5 minutes ago I was in San Antonio, you wouldn't know where I was. You need to know both pieces of information to get the current position. So not only what you have at any given moment is a function of what you started with plus what you've accumulated, you could also say where you are at any given moment is a function of where you started plus your displacement, your net change in position since that time. So you can kind of see how this is going to be relating to motion as well. So yeah, it is just your FTOC1, which is your net accumulation added to your starting value. Now, when I hit enter, I should get what? 6.33333. So we don't even need to hit enter, do we? We know it's going to be that. Okay, very good. Huh? Do we? Can y'all live with that, or is that going to be? It's going to be one of those. What would Kilford call it? Is that what cognitive dissonance is? No, that's when two things don't reconcile. This is just a brain itch, right? Hit enter, please. Hit enter. Hit enter. I want to see it. No, we're not. We're not. Just live with it. Okay. Learn to live with it. Okay, here we go. In the previous example, the first method relied heavily upon our ability to find the antiderivative, right? We had to find the antiderivative plus c, but it's not always easy, possible, or prudent. I wonder what that circumstance would be. I don't know. Let's go ahead and hit enter. Okay. Hey, the calculator is as smart as we are. Okay, so being able to express a particular value of a particular solution to a derivative is of paramount importance. Ooh, paramount importance. Especially when you don't know how to find the general antiderivative. So, hard facts to refute. Maybe this will come up in the Republican debate tonight. Okay, hard facts to refute. Where you are at any given time is a function of where you started and where you've gone from your starting point. Is that right, Marco Rubio? You started with nothing, and now you have a lot of stuff that you can't pay for. What you have at any given moment is a function of what you started with plus what you've accumulated since then, right? Now, when we say accumulated, that means net accumulation. So it also means it takes the loss into account, right? Like when Trump filed for bankruptcy in his Jersey casinos, right? He lost those. It's part of the net accumulation. So later on, we're going to have problems where we have like a big old tank full of Kool-Aid or something, and they're starting off with like 55 gallons of Kool-Aid in the tank. But Kool-Aid is draining from the bottom of the tank at a certain rate, and someone is filling the top of the tank up with Kool-Aid at a different rate. And we might be interested in how much Kool-Aid is in the tank at any given time, right? So if there's a different rate for how fast something is leaving versus how fast it's coming in, you can kind of modify it to say the amount at any given time is a function of the current amount plus what you've gained since that time minus what you've lost since that time. But in general, if you have a single rate equation that tells you how fast something's changing, the integral of that will give you the net change, okay? Kind of an important idea. All right, let's try police duty war. MOP, okay. There it is again, all right? There's a couple of asterisks there. And notice one asterisk means very important. So you can imagine how many that means. Yeah, why is this very important? This is basically all of Chapter 6. All of Chapter 6 deals with applications of this idea. And you could probably anticipate that maybe at least two, maybe more of your free response questions out of the 6 total that you'll see on Cinco de Mayo are going to involve this idea. And in 2010, four of the six dealt with this topic. Okay, 4 of the 6. Some were with numbers, some were with graphs, and some were with equations. Some were with units, they were applications, some were without. So, very important idea. All right, let's try example 19. If f prime equals 4 sine squared of 2x and f of 2 equals negative 2, using your calculator A through C only, okay, find the following. Be sure to show your integral setup. Golly, why did I yell that? For parts A through C. Yes, super important. Free response. Make sure that before you go to the calculator, you have thought it out, you have written it out, and you're using your calculator just to compute something that you've already kind of set up on your paper. Don't just start typing stuff in your calculator multiple times and get an answer and write it down, unless it's a multiple choice and you know what you're doing. Because remember, you're getting points for your process. You're getting points for the procedure that you're showing and communicating through your work, right? So I'll do A with you, and then you can do the rest. All right, so notice what we have. We have a rate equation, an f prime, that tells us how fast f is changing. We also have an initial condition. Now, I can do this one of two ways. If I want to find f of 3, that is the y value at 3, I can find the antiderivative of that, put my plus c, use this initial condition to find c, end up with a nice particular solution for f, and then just plug in a 3, get the answer, and then, of course, I would smile. But remember, doing that requires me to be able to find the what of this? The general antiderivative, right? Do we know how to do that yet? No, because it's sine squared. There will be a way using the power reducing identity. So once we get to the next section, we will be able to do it. But if this did show up on a calculator portion of the exam, and there are calculator portions of the exam, even if you know how to do it by hand, you get bonus points for doing it by hand rather than doing it on the calculator. No, okay? So it's not the time to show off. It's the time to actually use the calculator and let it do the work, even if it were a free response question. So having said all that, you first need to be able to recognize that this is one of those times where you could set it up as an integral. How do we know that? What's the giveaway? Well, it says to show your integral setup, but that's me. That's not the College Board's not going to give you that. Yeah, we're trying to find a y value at 3. We have a rate equation, and we have an initial condition, and that's why we call them initial conditions. Initial doesn't necessarily mean we're starting at x equals 0 or t equals 0. Initial condition just means it's a seeding value. It could be anything. It's essentially where we're starting at any given time. So here we go. F of 3, I'm going to go ahead and write it out, is a function of where we started. Where did we start? -2. Yeah, you don't have to write f of 2. If you want to put -2, that's fine. Plus our net accumulation from when we were at -2, which was what x value? 2, to where we're trying to get, which is what? 3. So what's important is that the one you're trying to find is on top, and the one that you're starting with is on the bottom, the x value. That's important. Of your rate equation, 4 sine squared of 2x. Now, if this were a calculator question, you wouldn't even need to write that. This is kind of more what you do if you have to do it by hand, because you have the expression of the function there. So you could just say f of 3 equals f of 2 plus the integral from 2 to 3 of f prime of x dx. Either one of those would give you more than likely 2 checks on any free response. That's pretty good, because all free response questions are worth 9 points. So this would be like a 3-pointer. No. I'm sorry. Yeah, mix and match if you want. Instead of putting f of 2 there, you could actually put what f of 2 is. Yeah, it doesn't necessarily need to be all in terms of f or something. All I'm saying is that, this integrand here just takes a little bit more keystrokes with your hand writing it out than f prime of x. And if this is an ugly function or there's multiple terms, it's just safer to put f prime of x. That's its name. You don't have to worry about parentheses or transcription errors, right? And maybe you put 4 sine squared of x. I know I could do that pretty easily. You missed the double angle, and now you have it wrong. So if it's a calculator question, especially, just try to use the name when you can. You can do that on a non-calculator as well, and then go to another line and write the expression so you can work with it. And then you've locked in the point. Okay, so go ahead. If you have a calculator, figure it out. I'll do the first one with you. If you need to borrow one of mine, feel free. I'm going to let you do the other ones. Okay, so that's us.
You can please turn your TV to channel 4 for the morning announcement. You can also view them online at mbhstv.com.
Okay, so when you have to use a function multiple times, namely f prime, it's going to be worth typing it into y1 and then just recalling it for y1. And the bigger and uglier the function is, the more this is beneficial. How do you square a trig function on your calculator? Well, unfortunately, the way I have it typed in right there, your calculator recognizes that as not just squaring the angle 2x, it recognizes that in its program as squaring the whole sine function. So if you're aware of that, you can type it in like that. But if you wrote it like this on your paper, it would be wrong because we would assume that you're just squaring the angle. So I'm not really a big fan of that, but it does work. So if you want to just reinforce proper notation, there's no way to type it with the shortcut, sine squared of 2x. So I put parentheses, sine of 2x, close it for the angle, and then close it for the function. And now you're clearly squaring the whole function, which was how you would write it in expanded form on your paper. So there it is. There's the function f prime. And now you can go to the home screen if you want. And then your template, you can almost just type it in once and then recall it. -2 plus math 9. And the lower bound is 2. The upper bound is 3. And again, you can recall y1 by hitting alpha trace. Or vars, y vars, function, enter. Make sure you're pulling up the right equation. If you have your equation in y2, make sure you select y2. And then dx. All right, so I've already written it on my paper, my iPad. I hit enter. I let the calculator do all the work. And then all I have to do is write my answer down underneath there. So I won't use a highlighter though. F of 3. And then again, how many decimals do we report? 3. So 762 or 0.763, round or truncate. Okay, so does that give us the net change? No, that one gives you the position. Okay, that basically tells you what you have. Remember, the integral is your displacement or your net change. You add it to the initial condition to get the current amount or the current position. All right, so if we do it for the others very quickly, the setup is going to be almost identical. F of 5 equals -2 plus the integral from 2 to 5. The only thing that changes is the upper bound. So while y'all are doing that, I'm going to go ahead. I wrote it on my iPad. I'm just going to recall it. And then all I got to do is scroll back up here and change my upper interval of integration. So I get 4.038. The good thing about this is if you ever integrate from left to right, or right to left, I should say, like in the next one, f of -2, you don't have to really do any of the thinking because the calculator and the setup itself will handle it. You're going from 2 to -2, which is backwards. But if you set it up like that, it's going to take care of the sign all on its own. Second enter, I think, is still a quicker way to recall the previous line than scrolling up and grabbing it. Is it being -9.010 or 011? What do you think f of 2 is going to be? What should f of 2 be? Yeah, just -2. Because if my upper limit of integration is just 2, then the net accumulation from 2 to 2 is 0. And it should just be my initial value. And the calculator knows that. So that's just to help you see a pattern. Here's what you have to do sometimes as well. Not just evaluate it at a specific value. You might actually have to come up with an integral equation for f of x. So if you notice, the only thing that was different was that our upper bound changed. This was f of 3, and we changed our upper bound to 3. This one was f of 5, we changed our upper bound to 5. This one was f of -2, we changed our upper bound to -2. So in general, we could say that f of x, in general for any x, is our starting value of -2 plus the net accumulation from when we were at -2, which is 2 to some x value, of f prime of what? X dx, question mark? No, this is where you want to be careful. We've been using f prime of x, the whole time. But as soon as you make it a function of x, your upper interval or your upper limit to your interval becomes the variable. So as we already mentioned, you have to switch variables there. And here's the good part. It's your choice, dealer's choice. What do you want to use? Schroeder, what do you want to use? What letter?
Let's go for X.
Ooh, my S's look like 5s. Ah, nice. You know me. Yeah, f prime of s ds. College Board typically uses t, of course, right? Because time is another variable we use a lot. But you could choose. As long as it's something different than x, now there's no confusion what the independent variable is, right, when you say f of x. All right, so on any free response question, you might have to do it specifically for values. You might have to write a specific equation. A lot of the times they'll say write an integral equation but do not evaluate it as a function of x. And sometimes you're doing this first and then evaluating it at points. Sometimes they have you do it specifically at points and then you come up with the general equation. So both of them are tied into the same idea. This is just the important thing to remember to change those variables to something else. No, you actually don't, and that's a great question. Here's why. The name of this function, the name of this function is f prime. That's its name. Hey, f prime, how you doing? Oh, pretty good, okay? X is just an independent variable. So When you say f prime of s, did we change the name of the function? No. Hey, f prime, how you still doing? Still doing good. Hey, Coach Fair, how you doing? All right, cool. Yeah. Did that answer your question? Yeah. Okay, so the independent variable can be anything because you're really defining the independent variable back here when you put ds, okay? And you're not changing the name of the function. Now, if you wanted to change it to like g of x or g prime of x or g prime of s, I should say, or like petunia of s, then you need to say let f prime equal petunia or something. But there's no really need to do that. Okay. You got it? Pretty good? All right, let's try this one. If g prime equals e to the sine of x and g of 2 equals negative pi, find all these. But here's what I want to do. I want you to do this first. We're going to go backwards now. I want you to find an equation for g of x first, and then it comes down to, I guess, evaluating those. Rather than do it specifically with numbers and then come up with the general function, let's find the general function first, and then evaluate it. And that way, if we don't get to evaluate all of them on the calculator, you still have the template, and it's kind of a foregone conclusion. So we'll finish with example 20 today. And then I guess example 21 is the last one. We're not going to get to it today. So we'll finish tomorrow. The worksheet will be due on Monday still. Yeah. We will roll into the next section tomorrow. What you have at any given moment is a function of what you started with plus your net accumulation from that moment to where you are now of the rate equation. If you need to do it specifically with the number first to see the pattern or whatever, do it once, then switch it out, that's fine. All right, so in general, g of x is going to be our starting y value, which is what? Negative pi, plus the net accumulation from when we were at negative pi, which is at x equals 2, to where we're trying to get in general, which is x, of our rate equation of g, which is g prime of anything other than x. Let's use t. Good. dt. There you go. And now you can use that if you want. G of 2, now pretty easy. It's going to be negative pi plus the integral from 2 to 2 of g prime of t dt. And, of course, that's what? I can do that without a calculator. What's the integral from 2 to 2? 0. So negative pi plus 0 is negative pi. The rest of them you'll have to do on your calculator simply because e to the sine of x is not one that we're going to be able to find the antiderivative of. So I'll leave that as an activity for you to do at home and for the viewers to do at home. All right, so we'll finish tomorrow with a nice little application. This is kind of getting into what Chapter 6 is all about. Good day today. Good day.